So in the last video, we have seen that how repair alteration is carried out in a piping system. In the section 9, which is the final section of API 570 code, we'll be talking about inspection of buried pipings. Now, the piping that are buried are subjected to some other kinds of damage mechanism, which the pipe, when it's above the ground, they would not be the major cause of concerns of various kinds of deterioration. That means, first of all, we'll have to understand that the soil might have different number of constituents. You can have nitrogen, you can have some microbiology involved there. So in that case, you might need to check the piping system at frequent intervals. But in this case, it is not possible because you cannot excavate pipe and you can check more frequently. That means some cathodic protection means are needed, some coating needs to be applied so that you can extend the life of the pipe without frequent inspection. But obviously, how to do that is the recommendation given in ASME. Sorry, it's the recommendation given in section 9 of the API 570 code. So, inspection of buried pipings. The inspection of buried pipings is different from other process pipe inspection because significant exterior deterioration can cause by corrosive soil conditions, and inspection can be hindered by inaccessibility of the affected areas of the piping. So when the pipe is installed, it is above below the ground, then it is not obviously possible to excavate every time while we are doing inspection. Important non-mandatory references for the underground piping systems are API 574. Again, API 574 is just the supplemental document for API 570. So we'll talk about API 574 in the next series. But whatever API 570, the recommendations the API 570 is giving you, that has to be supplemented with 574 because it gives you some additional data. And also following the NACE documents SP 0102, 0169, 0274 and recommended practice of 0502 and API 651. 651 is cathodic protection. Okay, so cathodic protection, whenever you want to do API 651 is going to be the guiding document. Buried piping shall be inspected at the inspected to determine if determine its external surface conditions. The inspection plans shall be based on an assessment of the effectiveness of the corrosion protection system or cathodic protection systems, if any exist. Whether the pipe was coated and on inspection information about obtained from one or more of the following methods. During maintenance activity on connecting piping of similar materials, from representative portion of the actual piping, from buried piping in similar circumstances, from permanently installed thickness monitoring devices, from inspection conducted with remote visual inspection equipment if possible, from the results of cathodic protection surveys, or from guided wave examination used to locate the areas of interest for follow-up inspection using more quantitative thickness measurement techniques. Above ground visual surveillance. So first of all, if the pipe is below the ground, the first thing we are going to do is above ground surveillance. We might try to understand if there is any kind of leakage happens and if that leakage is detectable from the surface condition. If there is any kind of uh, pool that is created by the leakage, that can be understood by above ground surveys. Sometimes you can also notice some kind of odor associated with the process in which the pipe is working for above ground without excavating itself. The first thing is always going to be above ground visual surveillance. Indication of the leaks in the buried piping may include change in surface contour of the ground, discoloration of the soil, softening of the pavement asphalt, pool formation, bubbling water puddles, or noticeable odor. Surveying the root of the buried piping is one method of identifying the problem areas. Close interval potential surveys. The close interval potential surveys performed at the ground level over the buried pipe can be used to locate the areas where cathodic protection system may not be effective. The active corrosion on the piping surface is present or may occur. However, it is not a reliable method for corrosion wall loss inspection since it can only infer wall losses from the cathodic protection potential but not directly detect the presence of wall loss. So it can tell you that some kind of wall loss is happening, but it cannot tell you that what would be the thickness remaining or something like that. Corrosion cell can form both bare metal and the coated pipe where bare steel contacts the soil. Since the potential at the area of corrosion will be measured different from the adjacent area of the pipe, the location of possible corrosion activity can be determined by this survey technique. So you can identify the corrosion that is happening, but you cannot place any number on it. Okay. Next is pipe coating holiday survey. The pipe coating holiday survey, that is a direct current voltage gradient, can be used to locate the defects on a buried coated pipings. It can be used on newly constructed piping systems to ensure that the coating is intact and holiday free. Soil resistivity, one of the most important things here. So soil resistivity is basically how resistive the soil is to current flow. If the soil is very corrosive, if the soil is very resistive, then it is not going to let current pass easily. Hence, the galvanic cell corrosion will be limited. So if the soil corrosivity or the soil resistivity is very high, then the inspection interval can be very low because the corrosion is not going to be that extreme. If the soil resistivity is very low, this means the potential for galvanic corrosion will increase and there is a need to do a cathodic protection system, and a frequent survey is required to understand if the soil corrosivity is impacting our system or not. The corrosiveness of the soil can be determined by measuring soil resistivity. Lower levels of resistivity are relatively more corrosive than higher levels, especially in the areas where pipe is exposed to significant changes in soil resistivity. The measurement of soil resistivity can be performed by using a Wiener 4-pin method in accordance with ASTM G57. Next is cathodic protection monitoring. Cathodically protected buried process piping can be monitored regularly to assure the adequate levels of protection. Again, API 651 will give you the recommendation on the cathodic protection system. That is true for piping system as well as above ground storage tank also. Next is inspection method. The array of technologies are now available that can externally apply to buried piping at the location and screen the selected areas from that position. These techniques may require some excavation but considerably less than the full access described earlier. And examples of these techniques can be guided wave examination, previously known as long range UT or guided wave ultrasonics. These technologies may allow 15 feet or longer distances to be screened at one installation and provide the screening assessment of the pipe. The distance traveled and the degree of detection accuracy is the function of the applied technology and the piping conditions, including the degree of corrosion, external and internal coating, and soil conditions, the transported product type, and the number of accessories in the path of the signal. So it will, the results of these long range UT or guided wave examination will depend on all of these things. Next is frequency and extent of examination. The above ground visual surveillance, the owner user should, at approximately 6 months interval, survey the surface conditions on and adjacent to the buried piping path. Pipe to soil potential surveys for poorly coated pipes where cathodic protection potentials are inconsistent. The survey may be conducted at an interval of 3 to 5 years for verification of continuous corrosion control. The pipe should be excavated for inspection or inspection with the appropriate non-destructive examination at sites where possibilities of active corrosion cells can have been located to determine the extent of corrosion damage. A continuous potential profile or close interval survey may be required to better locate the activity of the corrosion cells. So sometimes pipe needs to be excavated. First, we'll need to understand how much active corrosion cells are there. Active corrosion cells is basically which area is acting more anodic, which area is acting more cathodic. Once we identify this, then we can take some corrective actions on it. Next is piping coating holiday survey. The frequency of holiday surveys is usually based on the indication that other forms of corrosion control are ineffective. Soil corrosivity, for piping buried in the length greater than 30 meters are not cathode and not cathodically protected. The evaluation of soil corrosivity should be performed at appropriate interval based on the likelihood of the change. External and internal inspection intervals. The external condition of the buried piping is that is not cathodically protected should be determined by either pigging, which can measure wall thickness, or by excavating according to the frequency given in table 4. Significant external corrosion detected by the piping or by other means may require excavation and evaluation even if the piping is cathodically protected. Piping inspected periodically by excavation shall be inspected in the length of 6 to 8 feet at one time or more locations judged to be more susceptible to corrosion. Excavated piping should be inspected full circumference of for the type and extent of corrosion and the condition of the coating. If the inspection interval reveals the damaged coating or corroded piping, additional piping shall be excavated until the extent of the condition or extent of the condition is identified or extent of damage is identified. If the average wall thickness is lower or below the minimum required thickness, it shall be repaired or replaced. If the piping is contained inside a casing pipe, the condition of the casing pipe should be inspected to determine if the water or the soil entered a casing. So you have a casing, inside that you are flowing a pipe. So if any leakage happens, that casing pipe is going to protect that leakage from entering the soil. This is the casing pipe. If the casing pipe has a problem, then it has to be replaced. First, you have to check if casing pipe has some kind of liquid or not. If there is some kind of liquid, there is a high chance of the leakage happening in somewhere in the piping system. Both ends of the casing extend beyond the soil surface. The ends of the casings are sealed if the casing is not self-draining. The pressure carrying pipe is properly coated and wrapped. There is no metallic or electrolytic contact between the casing and the pressure carrying pipe. Next is leak testing intervals. An alternative or supplement to the inspection is leak testing with liquid at a pressure at least 10% greater than the maximum operating pressure at intervals half the length of those shown in table 4. For piping not cathodically protected at the same intervals as shown in table 4 for cathodically protected piping. That means whatever is written in this is for cathodic protection. If there is no cathodic protection, then you can use without cathodic protection table. If cathodic protection is done, then it is half the length which is given in table 4. The leak test should be maintained for a period of 8 hours. That means you have to sustain the pressure for 8 hours, 4 hours after initial pressurization of the system, and the pressure should be noted and if necessary the line pressurized to the original test pressure and isolated from the pressure source. If during the remainder of the test period the pressure decreases more than 5%, the piping should be visually inspected externally or inspected internally to find the leak and assess the extent of corrosion. Sonic measurements may be helpful in locating leaks during the leak testing. Sonic measurement is measurements of sound, acoustic emission. During buried piping also may be surveyed for integrity by using the temperature corrected volumetric or pressure test methods. Other alternative leak test methods involve acoustic emission examination and addition of tracer fluids to the pressurized light. So tracer fluids is generally halogen tracers or refrigerant tracers. If the tracer is added to the fluid service, the owner user shall confirm the suitability for process of the product. So in this case, if the soil resistivity is less than 2000, inspection interval is 5 years. If it's 2000 to 10,000, the inspection interval is 10 years. And if it's greater than 10,000, the inspection interval is going to be 15 years. More resistive the soil is, the less amount of corrosion it can do. Okay. Next is repair to the buried piping systems. The repair to the coatings. Any coating removed for the inspection shall be renewed and inspected appropriately. For coating repairs, the inspector should assure that the coating meets the following criteria. It has sufficient adhesion to the pipe to prevent the under film migration of the moisture, so it should properly stick to the substrate. It is sufficiently ductile to resist cracking. It is free of voids gaps in the coating. It has sufficient strength to resist damage due to handling and soil stresses. It can support any supplemental cathodic. It can support any supplemental cathodic protection. In addition, the coating repairs may be tested by using high voltage holiday detectors, or you need to do holiday surveys for inspecting the coating if there is any holes in the coating or if there is any delamination or something like that happening. Clamp repairs. In general, the bolted clamp should be avoided for temporary repairs to all the buried piping. If the piping leaks are clamped and reburied, the location of the clamp shall be logged in the inspection record and may be surface marked. Both marker and the record shall note the date of installation and the location of the clamp. All clamps shall be considered as temporary. Temporary repairs on a buried piping should be permanently repaired at the next maintenance opportunity unless approved for the extension by the piping engineer. So the same thing when we were talking about temporary and permanent repairs. So whenever a clamp is used, it is considered to be a temporary repair. Temporary repair has to be replaced by a permanent repair at the next maintenance opportunity or unless approved by the piping engineer. Welded repairs are given in 8.2. Records: the system for buried piping should be maintained in accordance with 7.9. In addition, a record of a location and the date of installation for temporary clamp shall be maintained. Also, buried piping should be located on a drawing indicating the size and external corrosion mitigation. So that is it for the API 570 code. You have annexes. So Annex A is inspector certification. What is the qualification and how is the certification process going to be for API 570 authorized inspector? Annex B is a request for interpretation, the interpretation that you want to request from the API governing body or the committee which amends this code at every frequent interval. Examples of repair: here example of a repair is given. These are informative. Then finally in Annex 4 we have how to determine the maximum allowable working pressure in using a half corrosion half-life concept. We'll talk about this later on when we are calculating the problems associated with API 570. But that's it for the 9th section. In the next series we are going to go for the next document, that is API 574 for API 570 examination. Thank you.